Hi, welcome to fractions. Before we get started on fractions, let's review some stuff about multiplication. One of the first things we want to review is the fact that multiplication of two numbers is commutative. You can multiply two numbers in any order and get the same answer. For instance, 5 times 3 is equal to 3 times 5, which is equal to 15. Any order that you want to multiply in, you can. This is an important property, and I would like you to remember. Next, we need to think about how multiplication and addition work together. This is what you remember from high school as being the distributive property. But you notice that this sentence can be read in two directions. In this direction, we distribute A times B plus A times C. In this direction, we're factoring. Notice we factor out an A times B plus C. This is factoring. This is distributing. This is probably the single most important skill that we're going to utilize today to understand fractions. Between factoring and distributing and the reciprocal, you're good to go. Let's try an example here. 5 times 3 plus x is equal to 15 plus 5x. Now, if we saw 15 plus 5x, we would think, well, 15 is 5 times 3, so I can pull out a 5. And indeed, how you would do that is going this way. You would end up, starting with 15 plus 5x, we would end up with 5 times the quantity, in parentheses, 3 plus x. The take-home message here is parentheses are your friend. Okay, let's think about this example. What could we factor here? How can we factor this? This is hard. Factoring is harder because you have to see the common factors. Distributing is easy because you know what to distribute and you just go ahead and do it. The beautiful thing about how these work together is when you factor, you can check if it's correct. By then, following that, you can do a distribution and see if what you got was what you started with. So here, what we notice is that both of these have a common factor of 2a. So this is where we want to start. We want to remove a 2a, and then what's left? Over here, we're going to have an a, because 2a times a is 2a squared, and over here, we're going to have a 2. And that is how you factor in a nutshell. The most important thing after I've shown this to you is that you need to practice and practice and practice. So please take my advice and practice. Okay, now let's clear the decks and prepare for the reciprocal. Dividing by a number, which is the essence of fractions, here a, this is a divided by b. The essence here is that a, this is the same as a times the reciprocal of b. So if we really want to understand fractions and division, what we need to understand first is this notion of reciprocal. And that's what we're going to talk about now. The definition of reciprocal, if we have any number x, its reciprocal is the unique number so that x times its reciprocal is equal to 1. This is the definition and key, and I need for you to remember this definition. Notice, if we rearrange this equation using our algebra skills, we get r is 1 divided by x. So the reciprocal of x, which is r, is 1 over x, which sometimes, or all the time, we denote using this notation of minus 1 power. So anything to the minus 1 power denotes a reciprocal. So the reciprocal of x, x to the minus 1, is 1 over x, and it has the property that if we take a number and we multiply by its reciprocal, we end up with their product being equal to 1. This is super important. I need you to think about this. I need you to remember the definition, and I need you to be able to use that in practice. And what that means is you should practice. Okay, let's consider an example. What is the reciprocal of 5? Well, the reciprocal of 5 has the property that 5 times r is equal to 1. So in fact, r is equal to 1/5. And what we know is that 5 times 1/5 is equal to 1. This takes us back to high school math, but it's super important. Now let's work on this using symbols. Actually, before we consider some examples, let's consider a not example, the most important not example that there is. And the question is, why does 0 not have a reciprocal? And the answer is simple. So if 0 had a reciprocal, then the reciprocal would have the property that 0 times r would be equal to 1. But we know that 0 times anything has to be 0. In this case, if 0 had a reciprocal, no matter what we called it or what its symbol would be, we would have the fact that 0 equals 1. And that, my friends, is a contradiction, and the reason why the reciprocal of 0 is undefined and it is undefinable. Every number that is not 0 has a unique reciprocal. Notice also that the reciprocal is precisely what lets us cancel. What is cancellation? Cancellation is the fact that a number times its reciprocal is equal to 1. So we can replace that product of b times b, its reciprocal, by 1. This is, for instance, why 5 divided by 5 is equal to 1. And if we see 5 over 5 in an equation, we can cancel it. What we're saying when we cancel things is that their ratio is equal to 1. Why is 5 over 5 equal to 1? Because 5 over 5 is equal to 5 times 1/5, which is 5 times 5 to the minus 1. It's reciprocal. This set of equations that we've written here at the bottom, you should be able to write this for yourself. For any number, 5, 7, pi, cosine of 30 degrees, whatever you like, you should be able to reproduce this set of this progression of ideas that leads to cancellation and the reciprocal. Make sure that you understand this. Cancellation is the result of finding the product of reciprocals. This is super important. So anytime that you have a product and you require a product, so product means multiplications of things. Let's clear the decks here and do an important example that I've seen students do over and over and over again. Okay, so let's consider the following problem. Let's simplify a squared b cubed c divided by abc. And the idea here is that we're going to look in the numerator. We're going to use the fact that we can multiply things in different orders and that powers mean products. So for instance, we can rewrite the numerator here as a, b, c times, let's use parentheses here, they're our friends, times a, because a times a is a squared. We got left over how many b's? We got 2 b's, b squared, and we got no c's because we used our c. There's only one c. And when we divide this by ABC, we notice that in the numerator we have a product of ABC, and in the denominator we have a product of ABC. That means the denominator is the reciprocal of the numerator, which means that this ratio of ABC divided by ABC is equal to 1 times AB squared over 1. Or the whole thing really ends up just being AB squared. And that is how and why cancellation happens. Because right here we have the same numbers or expression in the numerator as in the denominator. The expression in the denominator is the reciprocal of that in the numerator. So their ratio is equal to 1, which means we can cancel it. That is precisely and exactly how cancellation works, and no other way. So if you've been able to follow our presentation so far, what we've discussed is the definition of reciprocal. So the reciprocal of a number, any number x or symbol, is r, and the product of reciprocals is equal to 1. This is our first point, not to be confused with the number 1. And this, we can also write this as x times x inverse equals 1. The only number that doesn't have a reciprocal is 0. 0 has no reciprocal. And we demonstrated why that was true. That's exactly why we can't divide by 0. Dividing by 0 means that 0 would have a reciprocal. So we can't divide by 0 because 0, the reciprocal of 0 cannot be defined. It conflicts with all of our other definitions and would ruin the party. So we throw it away. It's like you got a bad party guest, lock the door. That's how it goes. 0 has no reciprocal. And what was the third thing? The third thing that we've learned so far is that cancellation, when you have fractions, cancellation results when you have a product of reciprocals. I'm running out of space, but you get the idea. So these are the 3 take-home messages that you should have learned from this little bit on reciprocal. Now we're going to clear the decks and we're going to move on to multiplying, dividing, and adding fractions. Okay, well, we're not quite out of the reciprocal woods quite yet because there's one fact that I forgot to tell you about. So what is the reciprocal of a product? So what is the reciprocal of a product A times B? Well, whatever that reciprocal is, it has to satisfy this following equation. This is what we know. A times B times the reciprocal is equal to 1. So if we can find a number or an expression that when we multiply it times A times B we get 1, that thing will have to be the reciprocal. Okay? So let's observe the following thing. Let us multiply times the reciprocal of B and the reciprocal of A. Both of those, both A and B, if their product is non-zero, then they both have to be not zero. So the product AB, each of A and B has a reciprocal, so there they are. Okay, now what do we know? Well, first of all, notice this. Because we can group things, what's B times its reciprocal? We already said that that is equal to 1. Okay, hopefully you recognize that. So that means that this equation is the same as A times the reciprocal of A, which again is equal to 1. So all in all, what have we just demonstrated? We've just demonstrated that if we multiply AB times B inverse A inverse, that is the same thing as multiplying by the reciprocal. And since reciprocals are unique, we just have demonstrated that B inverse A inverse is equal to AB inverse. So the reciprocal of a product is the product of the reciprocals. Okay? That's kind of an important fact that we're going to use in just 1 second. To illustrate, what is the reciprocal of 15? The reciprocal of 15 is 1 over 15. But 15 is 5 times 3. So we know that the reciprocal of 15 has to be equal to the reciprocal of 5 times the reciprocal of 3. So in other words, we just showed that 1 over 15, the reciprocal of the product, is equal to the product of the reciprocals. And what's interesting here that you notice, or should notice, hopefully you noticed, is that here we have 3 times 5 in the denominator and 1 times 1 in the numerator. And when we just simply multiply the numerator, we get the numerator of the other fraction of the left-hand side, and if we multiply the denominators, we get the denominator. And this, in fact, turns out how you multiply fractions in general. You multiply the numerator, you multiply the denominator, and you get the answer. And we're just about to demonstrate that that's true in general. But there you have it. So to multiply any two fractions, let's look at A divided by B times C divided by D. Well, let's rewrite this. So let's rewrite this as A times B inverse, that's our first fraction, and that is multiplied times our second fraction, which is C times D inverse. But now, because we know that we can multiply in any order, what we can see is that this is the same as A times C. Let's put some parentheses here. Now let's multiply times B inverse D inverse. We recognize that as A times C times B times D inverse, which we can now write as a single fraction, A times C divided by B times D. And that's how you multiply fractions. You multiply together the numerators, you multiply together the denominators. And the reason why that's how you multiply fractions is because of this property of the reciprocals. The reciprocal of a product is the product of the reciprocals, and multiplication is commutative. Those two facts underlie this. So now let's do some examples. How about we start with 7 over 3 times 4 over 5. So we multiply the numerators. 7 times 4 is 28. And if we multiply the denominators, 3 times 5 is 15. And that's how it works. With numbers or symbols, it's always the same. First thing to notice, though, is that if we wanted to simplify or cancel anything, we'd have to look for common factors first. 7, 3, and 5 are prime numbers, so they can never cancel each other because they have no common factors by definition. 4 is not prime, but none of the other, because nobody else, because everybody else is prime, there's nothing to cancel the 2's with. So the best we can do here is to say that the product of these two fractions is 28 over 15 and leave it at that. Let's try another example. Alright, in our next example, let's consider 12 divided by 7 times 14 divided by 3. So before we start, we can multiply everything out, but we might as well write things out in terms of their factors. So 12 we can write as 3 times 4, and 14 we can write as 7 times 2, and the denominator has 7 times 3. Let's write that as 3 times 1 times 7 times another 1. And the reason why we're going to do that is because now we notice that we have a 3 divided by 3 times a 7 divided by a 7, and both of those things are equivalent to a 1. That's what we figured out earlier. So what we have here at the end of the day, this boils down to 4 times 2 divided by 1, or just 8. Anything divided by 1 is just itself. Okay, and this illustrates how we can cancel things. I encourage you to rearrange things in order like this before you get more fancy and to practice. Now we're going to use the reciprocal to figure out how to add fractions. So let's start with a over b. It's always our go-to fraction, right? A over b plus c over d. And the first thing to do is let's rewrite this as multiplication. A times b inverse plus c times d inverse. Okay? And now we're going to use the following fact. Let us multiply. Actually, we're going to do the opposite of cancellation here. A times d inverse b inverse. That's our first term here. Notice that all I've done is insert a term which is equal to 1. So in fact, multiplying by 1, I haven't done anything. Correct? Plus, and here, what do you think I'm going to insert over here? Well, if there's any justice in the universe, I'm going to insert b inverse, d inverse. Okay? And now, well, why did I do that? And how did I do that? You notice that b times b inverse is just another copy of 1. Okay? Now, let's see what we've gained here. Both of these terms have a common factor, and that's d inverse times b inverse. So let us factor that out of the expression, okay, like we did in the very first part. So we're going to factor out d inverse times b inverse, and what's left is a times d plus c times b. What is that horrible crazy squiggle? Let's get rid of that. And this just miniaturized everything so we have a little more room. And this, you'll notice, is the fraction a d plus b times c divided by b times d. And if you've worked with fractions before, you know that b times d is the common denominator, and that's what we've done. We've demonstrated that when you add fractions, what you do is you find a common denominator to combine them into a single fraction. Okay? So we've used what we learned about factoring, which is the opposite of distributing. We learned about factoring, and we used the reciprocals to figure out how to add two fractions. So now let's do an example. How about we add 2/3 plus 5 over 7. So the way we do that is we find a common denominator, which in this case will be 21. We multiply the fraction on the right hand side. We can think about this as multiplying by 7 over 7 times 2/3 plus, and on this side we're going to multiply 5 over 7 by 3 over 3, and we know how to multiply fractions. We just multiply numerator and denominator, and you see that we're going to get a common denominator of 21. So on the numerator we're going to have 14 plus 15, and that will be divided by 21. So at the end of the day, what do we get here? This is going to be 29 divided by 21. And that is how you add fractions. Can we cancel anything? Look to try to cancel stuff. I don't see anything obvious. Okay, so let's clear the decks and move on to the very last subject that we're going to talk about here, which probably is the most confusing, and that is dividing two fractions. You already know how to divide fractions because we've discussed the reciprocal. The reciprocal is what it means to do division. So for instance, if we have 1/7 divided by 2/5, this is the same as saying this is equal to 1/7 times the reciprocal of 2/5. What is the reciprocal of 2/5? The reciprocal of 2/5 is 5/2. So now, and we still remember how to multiply two fractions together. You multiply numerators and denominators. The answer here is 5/14. How do we know that 5/2 is the reciprocal of 2/5? Well, let's look. What's the property of reciprocals? If you multiply them together, they have to equal 1. Now you know that we can multiply in any order. So this is 2/2 times 5/5, which we know from the fact that you've been paying attention to all the stuff I've been saying about cancellation, is that this is equal to 1. So in fact, 5/2, this is multiply, not subtract. So 5/2 is in fact the reciprocal of 2/5. So 1/7 times the reciprocal of 2/5 is 1/7 times 5/2, and that product is 5/14. And this is how you divide fractions. Dividing is the same as multiplying by its reciprocal. This is the most important thing that you need to remember, and I'm going to write it down right now so that maybe it sinks in. Dividing by x is the same as multiplying by the reciprocal. Okay, whatever that reciprocal may be. So that's what you have to think about when you see a fraction or you're talking about dividing two fractions. It's no more complicated than just dividing any other two numbers. All you have to think about is taking it one step at a time. Find the reciprocal of the denominator and multiply. That's it. End of story. Well, I hope these slides have helped. Thank you. And the end. Come find me and ask me for help if you need any more help involving fractions. The most important thing is to practice, so go online, go to Blackboard, find yourself a practice sheet, and just practice the fundamentals. Thank you.